At an altitude of nearly 4,000 meters on the wind-swept Altiplano of western Bolivia lie the ruins of a construction project that modern engineering cannot fully explain. The site is called Puma Punku, meaning the door of the puma, in Aymara. It is part of the larger Tiwanaku archaeological complex, about 70 kilometres from La Paz, and scattered across this barren landscape are stone blocks that were cut with a precision that should not have been achievable by any known pre-Columbian civilization. Tonight I want you to tell me, how did a culture with no iron tools, no written language, and no wheel-cut stone to tolerances of less than a millimetre? Comment below. The blocks at Puma Punku are made primarily of red sandstone and andesite, a volcanic stone that ranks between 6 and 7 on the Mohs hardness scale, comparable to steel. Andesite cannot be worked with copper or bronze tools. It requires something harder. The nearest known source of the andesite used at Puma Punku is a quarry approximately 90 kilometres away. The largest blocks weigh over 100 tonnes. They were transported across rough terrain uphill to an elevation of 3,800 metres. The precision of the stonework is what makes Puma Punku extraordinary. The H-blocks, distinctive eye-shaped stone pieces found at the site, are cut with perfectly flat surfaces, sharp right angles, and precisely drilled holes. The surfaces are smooth to the touch. The angles are exact. Multiple H-blocks are virtually identical to each other, suggesting they were manufactured to a template or standard, a concept more associated with industrial production than with pre-industrial stonework. Some blocks contain channels and grooves cut into their surfaces with a regularity that implies mechanical tooling. These grooves are uniform in width and depth along their entire length. They contain right angle internal corners, something that is extremely difficult to achieve by hand, particularly in a stone as hard as andesite. A right angle internal corner requires the cutting tool to reach into a confined space and remove material precisely. Modern masons note that achieving this in granite or andesite typically requires power tools with diamond-tipped bits. The interlocking design of the blocks is another anomaly. Many pieces at Puma Punku were designed to fit together without mortar, using a system of interlocking joints and metal clamps. The clamps were made by pouring molten metal, likely a copper arsenic nickel alloy, into channels carved between adjacent blocks. Analysis of these clamped channels has shown that the metal was poured on site, suggesting a portable smelting capability. The alloy itself is noteworthy. It is not pure copper, but a specific mixture that improves strength and resistance to corrosion. The conventional dating of Tiwanaku and Puma Punku places the site between approximately 500 and 1000 CE. However, the dating is contested. Arthur Posnansky, a European engineer who studied the site extensively in the early 20th century, proposed a date of approximately 15,000 BCE based on archaeoastronomical alignments of structures at Tiwanaku. While Posnansky's dating has been largely rejected by mainstream archaeology, the question of precise dating remains complicated by the fact that the site was heavily damaged, likely by both natural events and later human activity, before systematic archaeological study began. The Aymara and Quechua people of the region have their own traditions about Puma Punku. They say the site was built in a single night by the gods, or that giants constructed it before the Great Flood. When the Spanish arrived in the 16th century, local people told them that the ruins were ancient beyond memory and that no one knew who had built them. The mainstream archaeological explanation is that the Tiwanaku civilization developed sophisticated stoneworking techniques over centuries, using harder stone tools, abrasive sand, and patient labour to achieve the precision seen at the site. This is possible. Given enough time, skill, and coordinated labour, pre-industrial societies could achieve remarkable results, as demonstrated by Egyptian pyramids, Roman aqueducts, and Incan walls at Sacsayhuaman. However, Puma Punku presents challenges that these other sites do not. The H-blocks are not unique, one-off masterpieces. They are standardised components, interchangeable parts manufactured to identical specifications. Interchangeability implies measurement systems, quality control, and a manufacturing process capable of producing repeatable results across dozens of pieces. This is a conceptual leap beyond carving a single beautiful block. It is engineering The drilling is another problem. Several blocks at Puma Punku contain holes drilled to a consistent diameter and depth, with smooth internal surfaces. Core drilling, removing a cylinder of stone by rotating a hollow tube against the surface, is the most efficient method for producing such holes. Core drilling in andesite requires significant downward pressure and a cutting medium harder than the stone itself. Whether this was achieved through stone tools and sand or through some other means, the consistency of the holes across multiple blocks suggests a reliable, repeatable technique. Puma Punku does not prove extraterrestrial intervention. What it proves is that a civilization we know very little about achieved a level of engineering precision that challenges our assumptions about what pre-industrial societies were capable of. The blocks are there, the precision is measurable. The logistics of quarrying, transporting and assembling 100-ton andesite blocks at 4,000 metres above sea level are quantifiable. The question is not whether it happened, it clearly did. The question is how, and no one has provided a complete answer. Subscribe now and follow the evidence.